Basing an energy audit on poor data results in an expensive guess. It leads to wasted capital, missed savings, and unfulfilled efficiency goals. Many auditors face a critical challenge during the site visit: limited or absent metering equipment. Without baseline documentation, evaluating the energy demand of air conditioning and lighting becomes a matter of speculation. To calculate where and how much energy is being consumed, the audit must follow a structured three-step approach: desktop data collection, field data collection, and the cross-checking of load demand data. Before beginning, gather the prerequisites: 12 months of utility bills, building architectural and mechanical drawings, standardized data collection forms, and specialized measurement tools. Mastering this sequence allows you to move past theoretical estimates and identify the specific energy conservation measures that actually deliver a return on investment. Step 1 is desktop data collection. Gathering structural and historical data remotely minimizes the time and manpower required during physical site visits. Secure the essential documents upfront. You need a full year of electrical energy bills to establish a consumption baseline and the single-line power supply schematics to map the distribution. Standardized data collection forms organize this raw documentation and ensure no critical variables are missed before you arrive on site. On the historical consumption form, meticulously log the monthly maximum demand alongside both peak and off-peak electricity consumption to reveal the true cost of energy. Once the building totals are established, shift focus to evaluating the existing assets using the lighting and equipment data forms. Use the mechanical and electrical drawings to extract two metrics for every major asset: the rated power of the equipment and the scheduled operation hours. This desktop phase identifies your baseline costs and specific data gaps, transforming the site visit into a precision mission. Step 2 is field data collection. This is where direct observation fills in the missing gaps that cannot be resolved remotely. Physical assessments focus on building a true equipment inventory and assessing the building envelope for insulation quality, thermal bridging, and air leaks. You must also interview the facility staff to understand actual occupant behaviors and maintenance routines that dictate real-world energy use. Capture these conditions using proper tools: lux meters for lighting intensity, clamp-on amp meters for current draw, and data loggers for load profiles. Avoid trusting design blueprints exclusively. Aging systems and retrofitted equipment rarely operate at their original design specifications. Calculating is better than estimating, but measuring is better than calculating. Step 3 is cross-checking. Raw field data becomes actionable only once it is validated against historical utility records. Verify that the apportioned end-use calculations for HVAC, lighting, and general equipment align with the main incoming utility bill. Recording data for too short a duration is a major failure point. A 1-hour snapshot misses the cyclic variations of a running facility, skewing the entire profile. To capture a full operational cycle, record HVAC system load cycles for 1 to 7 days. The main incoming supply requires 7 consecutive days of logging to build a reliable load profile. If your calculated field totals match the historical utility bills after applying these durations, the baseline data is officially verified. Completing the desktop, field, and cross-checking steps builds a verified, highly accurate energy consumption profile of the facility. This data provides the foundation required to identify viable energy conservation measures. As shown in the workflow, once load apportioning is validated, data collection transitions directly into analysis and implementation. Accurate data allows you to deploy targeted upgrades, such as replacing aging units with high-efficiency variable air volume systems, or using thermal storage to shift cooling loads. The first step toward those savings is proper documentation. Download the sample desktop data forms in the description below and begin the preparation for your next audit.